Hello everyone, I'm Chanjana, a final year student from Abbott University, and my research title is Explainable AI Agent-Based Decision Support for Predicting Shipment Delays in Supply Chain. When we look into the problem domain, supply chain basically covers the entire life cycle, starting from the raw materials to the final customer delivery and payment. And shipment delays mainly disrupts and can lead to financial losses and customer dissatisfaction. Again, poor delivery also risks us from losing partnerships with our retailers and the distributors. In the context of the research domain, despite the significant advancement in machine learning in shipment delay prediction, supply chain is yet to fully diverge into the field of AI and autonomous agents. This is mainly due to the fact that employees and managers hesitate to trust AI without clear reasoning. And false prediction can disrupt business flows and cause product backlogs. So the problem statement for this research is the lack of accurate and interpretable predictions of shipment delays to support agent-based decision support systems. And the motivation is to develop feasible AI solutions to predict shipment delays. The research gap mainly to get the requirements, we did elicitation methods like literature review and self-evaluation and brainstorming. So the existing research mainly emphasizes the trust, the transparency, and the compliance in AI-driven decision support systems. However, inherent interpretable models like EBM are being rarely explored in this context. And even with some researchers like Colantino in 2025, research compared EBM with the black box model ANN, but they didn't evaluate the possibility of a post hoc explanation like SHAP alongside ANN. So this leaves us a gap of understanding the EBM in comparison to this hybrid approach in terms of both accuracy and explainability. So to overcome this, in my research, I'll be focusing on a comparative analysis where I'll be focusing on, I would like to evidence that EBM is it's a suitable model for my decision support AI agent that is to predict shipment delays. So moving on to that comparative analysis. First, so the data set that I selected for this research is supply chain Kaggle data set. And with that, basically, these are some of the attributes that we have. So it's mainly IoT based and other shipment data like user transaction amounts, user purchase frequency, logistic delay reasons, asset utilization, demand forecast, and it gives us the logistic delay. So firstly, I looked into the null values for the data preprocessing process, and I also got feature engineered for the timestamp. And when it comes to the target variable, I created a new variable based on the shipment status as it is being categorized into delayed, delivered, and in transit. For in transit, I replaced that amount with the logistic delay. So the new targeted variable is shipment delay. And again, looked into class imbalances and the correlation matrix for the targeted variable. And moving on, we also removed unnecessary and misleading features. And finally, with the train split, I trained my EBM model and I evaluated the performance. So this is the final output that we have got for our pilot test run. So here you can see we have an accuracy of 0.65 and we also have a ROC of 0.64. And the main benefit of actually using an EBM model. So first of all, I would like to show you the performance of other inherently interpretable models like GAM, rule fit, and decision support. So it's the same data preprocessing process that I've taken in the same data set. And in comparative to that, if we take the results, you can see the GAM is only 52% of accuracy. And for rule fit, it's 61%. And decision tree is 58%. So EBM really stands as a competitive, as a top accurate and interpretable model when it accurate and a transparent model in the class of interpretable models, right? So when that is being proven, now we'll also be looking into the black box models. So we have, so the EBM here has a 65% accuracy, right? And it also gives us the global explanation. So according to this, we can see that traffic status is highly high coral is being mostly prioritized when it comes to the feature importance of the overall model training. And you can see feature pairs have also been given, so how feature pairs behave within these predictions. And if we were to take a local explanation, if we were to take a local explanation, we can see the results. So if this was being predicted as not a delay, and what are the reasons? So traffic being clear has impacted a lot on this decision. So you can see that this transparency allows me, in the context of me being a logistics supervisor, to actually have a clear understanding of the decisions that I'm making. So I can easily apply the domain knowledge while being analytically sourced. So that's that. And again, so if we were to take our black box models, we also did the same uh, data pre-processing, but we also did one hot encoding, except for the CAD boost that doesn't require this pre-processing techniques. So for random forest gradient boosting, XGBoost, AAN, and SVM models and the CAD boost were trained. First, I'll actually show you the cat boost. So for the cat boost performance, we do have a good accuracy of 0.68%. So that's a 3% margin higher than the EBM. So that's, and the recall is a bit higher than EBM as is 0.588. And when it comes to the other models, we have the random forest, so that's 67%, 62%, XGBoost at 61%, and we have ANN as 61%, and we have SVM at 68%. And you can see from the recall of the predicted class, so in predicting recall, compared to the cat boost, SVM is slightly higher, but it's mostly coincide and very simultaneously these models are acting with the results. So, so something I came across is that when I am trying to apply SVM with the post hoc SHAP models to get the interpretable results, I came across that we cannot use tree explainers and we had to go for a kernel explainer. And this took a really long time, around 3 minutes and 46 seconds. And so there's a lot of computational overload when it comes to applying the SHAP models on SVM. On the other hand, cat boost having a very low margin change, but being as good as SVM in that terms of accuracy, was very easy to be used with the SHAP models, and therefore took as the best candidate from the black box to be compared for the overall comparative analysis with the EBM model. I have chosen CatBoost. And based on that, this is the global explanation for CatBoost. And what I've noticed is both of these models, global explanations, you do not see feature pairwise. So that is an added advantage from the EBM models aspect, but the traffic status, inventory level, and the latitude are both having feature importance for both models. And again, even for this, the first instance is being predicted wrong because of the because of the traffic state has been clear. So these are like insights that we can get through these explanations. But then again, EBM stands as a really stands in a higher level due to its transparency. Because some understandings that I have personally based on this research is if we were to take two scenarios where one scenario, a worker does a certain calculations and shows you the workings and tells you that this is why, this is the answer that I've got. Whereas another scenario, the worker says the answer is 2, and then someone else tells you that this is how the worker ended up with the answer to. So it's always feels right to go with the first solution, and EBM on this stands as a more accurate and a predictable model. So that comparative analysis needs to be further fine-tuned, where I will look into more like if I could go for an assemble stack with cat bulls, and so the other possibilities of improving the EBM's performance will be looked into throughout this research. And for the AI agent, so basically my AI agent, if I were to show you a structure, so basically the AI agent is, this is the rough UI that I have completed for the prototype for the midpoint review. So here what I mainly wanted to see is that if I started a new chat and if I give in, if I run a prediction, the data will be taken in from the AI agent and it will send it to the EBM tool. So this has our trained, so this EBM tool basically gets the, it's based on a node class, and in that we have the functions that calls our trained EBM models and sets the data and gets the predictions and the feature importance. So with that, we can see the results saying that this is being so here we have gotten the results saying the delayed probability is 74%, and these are the reasons, and so these are the feature importance. So the weather condition, the traffic congestion, and the career performance have affected this. So something I actually went through during this research is that I initially had a different data set and it had really low correlations compared with its targeted variable. So due to this, even when trying assembly models and other autoencoders and PCAs, none of them actually increased the correlations and gave me uh, a good results, right? It was close to random guessing. It was 0.51. So I had to go through other data sets and I finalized a new data set. And my current prototype was based on the old data set, and that is why you have a difference with these features, but that will be developed and everything. So the targeted time period for the ending to get the minimum viable product was by the end of November. So we'll be fine tuning all of this and prompting our AI agent, the LLM model, to give accurate and better results. So based on these, the email tool has not been integrated yet. So once you get the output and you can have a bit of a discussion with the LLM model, and uh, you can draft an email as well. So you can say. So an email will be given, and then basically we can send it to the customers. So that's the state of that's the current status of the research work that I've been completed. And thank you.